Now let's find the area of a parallelogram, and later on we'll also find the area of a triangle. We've discussed the basic theory behind this. Now let's do some questions, right? So it says that we have a parallelogram with these vertices A, B, C, and D, and we need to find the area. And again, you remember that the area of a parallelogram whoops, is basically equal to the base cross product of with the height, right? That's the magnitude of base cross height. So AB is equal to OB minus OA. Again, just basic vectors. And that gives you this. You find AC. Now you take the cross product of AB and AC, right? Because that gives you the height. And once you take this cross product using the method that we discussed earlier, again, just a reminder of how to do that. You first cancel out. You first multiply I. You just write down I, and then you cancel out its column, you cancel out its row, and you take the diagonal multiples. You multiply the diagonals and subtract them from each other. So I into 2 multiplied by 1, so that gives you 2, minus 3 into negative 1, so that gives you plus 3 basically, right? And then you write down minus j, right? That's a very important thing to remember. J is negative, I is positive, j is negative, and k is positive. That's just the convention. And so now let's just rub this off, and now let's take j. You cancel out its corresponding column, its corresponding row. Now you have 1, these terms remaining. Now you multiply the diagonal, so 1 into 1, that gives you 1 minus 3 into 2, so minus 6. And now plus k, right? Because only j is negative, I and k are positive in this convention. Now, when you take k, again, cancel out its corresponding row and column, right? Now you have this, this, and this, and this remaining. So 1 into negative 1, k into minus 1, minus 2 into 2, so minus 4, right? Now you have done the cross multiplication of AB and AC. And let me just clarify if I've written down this correctly. And yeah, indeed, this is what you get, right? And so this is the cross product of AB and AC. And as you know, the area of the parallelogram is basically the magnitude of AB cross AC. So you take its magnitude, and basically you end up with under root 75. Or basically 5 into under root 3 square units, because we do not know the units. They're not given to us. Now, let's find the area of a triangle. So the points P, Q, and R make a triangle. Now, as you know, the area of a triangle is basically half of the parallelogram that it makes, right? So half of the cross product, half of the cross product of base and height, right? Oops, sorry, this is a bar because it's a cross product. Now, PQ is equal to OQ minus OP, very obvious. PR, that gives you this. Now, you have the base and you have the height, right? PQ and PR, you have the base and the height. Now, simply, first you have to find the cross product of PQ and PR with the same method that we discussed earlier. Again, I'm not going to explain how this is done. It's fairly simple by this point. Now, expand R1 and you get the result of the cross product. Now what you have to do is simply take multiply half with the magnitude of PQ cross PR. So half of the magnitude of this vector here. So in the end, that just results in 15 by 2. square units or 7.5 square units.